Piecewise functions. This is a new type of function that we'll be studying. Here, let's get started. A piecewise function is a function that is a combination of one or more functions, usually more. The rule of a piecewise function is different for different parts or pieces of the domain. What we're going to do is break up the domain and then assign it different rules. And when we say a rule, we mean like a rule is x squared or x plus 3 or natural log of x, that kind of thing. So a piecewise function is usually defined this way. You're going to have the name of the function and then some algebraic expression or two or more algebraic expressions. And then you're going to have for what piece of the domain that one algebraic expression is used for. All right, and then another piece of the domain for the other algebraic expression. And A and B can be the same number, and they usually are the same number, but they may be different. All right, so here's one. So here's an example. We have our function f of x, and it's equal to 5 when x is less than 0, and it's equal to 3 when x is greater than or equal to 0. So this is how we're going to graph it. So first, let's graph this part, right? X less than 0, so that means we're going from here to the left. We're going from 0 to the left. It's less than 0. And we just get this. So it's y is equal to 5 for x less than 0. And then for x greater than or equal to 0, it's going to be to the right, right? So, and it's going to have the y value of 3. So it'll just be there. So that is the graph of this function. X less than 0, it's y equals 5. X greater than or equal to 0, it's y equals 3. I also want you to note that there's an open circle on the 5, but a closed circle on the 3 because of this relationship, right? Greater than or equal to. So the second piece claims the x equals 0 part, while the first piece does not claim the x equals 0. All right, let's do another one. So here we have 3 different pieces. So we got x less than -4. Here's -4 has a y value of -3. The next one, we're going from 2 for -4 to 3. From here to here, we're going to graph 2, y equals 2. And from x greater than or equal to 3, it's going to be y equals 5. So that's what we got. So we can have these pieces like this. All right, it's hopefully it's not too difficult. Let's continue. Okay, this is a little more sophisticated, though it's not too sophisticated. I'm missing commas. All right, so for x less than -5, this has the line y equals x. Now, if you forget how to graph a line, you just plug in the value. Even though this doesn't include -5, you can plug it into this. At x equals -5 has a y value of -5. You just put an open circle there, and since it's a line, and we're only graphing lines, you can plug in another point. Say x equals -6. If you plug in -6, you get -6. So then you can draw your line from there. Okay, or you can start. You still have, no matter what, you have to start with 1 point. So plug in -5, and I suggest the boundary. Plug in -5, get -5, and then you can apply the slope. But you got to apply the slope to the left, so it's going to be down 1, left 1. All right, remember to get a positive one, and you're going to the left. Remember, left is negative, so you're going to have to get 2 negatives to make a positive. So left and down will be left is negative, down is negative. Negative over negative makes a positive. Yeah, sorry, that was confusing. All right, but let's go on to the next part, -4 to 4. All right, now we're going to do the second piece. So we're looking at from -3 to 4. So here, it has a slope of -1. Plug in -3 into that expression. If you plug in -3, you get +3. There is a gap in the domain here, so it is going to be undefined for numbers between -5 and +3, but all right. So there's a gap here. That's a, I guess, discontinuity. Let's talk about this again. So when we plug in -3, we get a +3. It has a slope of -1, so it's down 1 over 1, down 1 over 1. Or you can just plug in another number like 0. If you plug in 0, you get 0. So you can just draw a line all the way up through where where this piece stops. So this piece stops at 4, and we put an open circle at 4 because it's not including 4. And then x minus 3 for the next piece. So here, that's where it is. I plug in the x value of 4. 4 minus 3 is 1. So I get a y value of 1. And then it has a slope of positive 1. Or you could just plug in the number 5 or 6 or whatever. Plug in 6. 6 minus 3 is 3. So you get a y value of 3. Remember, these are lines. We will be doing lines. Graphing lines is for our piecewise functions. So the example here, you can have gaps in the domain, as this one did, or you can have overlaps. Well, you can't overlap too much, right? You can only overlap at a point. If you overlap too much, then it's no longer a function, and it's just a relation. Although, I don't know why we make them sense. Alright, so now we want to be able to evaluate piecewise functions at specific x values. Alright, so we're going to plug a -8 into this. Right, so our notation, f of -8, we're going to plug it in to the correct region, correct interval. -8 is less than -5, so we have to use this formula, which isn't much of a formula. When we plug in -8 into x, we get -8. Alright, let's plug in -2. -2, it's this region. -2 is between -4 and 4. So we're going to plug it into the -x, so it's the opposite of what we plug in, and we get +2. And now let's plug in 4. Now let's be careful here. Where is 4? 4 is actually in the third region, because this is x is greater than or equal to 4, so that means it includes 4. So we're plugging in 4 into that expression. 4 minus 3 is 1. So the only thing different about piecewise function and evaluating values is just make sure you put it in the correct interval. Okay, move on. Oh, what if we had -4.5? Why am I testing -4.5? It's between these two, right? -4.5 is between -5 and -4. So this function is not defined because there's a gap between -5 and -4. So we say f of -4.5 is undefined. Okay. So in this video, we've done some simple graphing of piecewise functions. We're only going to be graphing lines, so that shouldn't be too difficult, and we should be able to evaluate the piecewise functions for any real values. So this will be more sophisticated in our function choices. You will get quadratics, exponentials, whatever, but since you're not graphing and you're only substituting, that shouldn't be too difficult. Well, that's it. Have a good weekend.